You may recall that in order to determine if a graph represents a function, we use something called the vertical line test, which I abbreviated as VLT, which said if we could draw a vertical line through that graph and it only touches one time, it's a function. If it touches more than once, it's not. It turns out there's a similar test called the horizontal line test, which I'll use HLT for, of course, which tells us if it passes, meaning a horizontal line only touches once, then the inverse of that graph is a function. If a horizontal line touches more than once, the inverse is not a function. So using these two tests, we can answer questions like, let's make a sketch of a graph that is not a function, but whose inverse is a function. So in other words, we want our first graph not to be a function. So we want it to fail the vertical line test. So I'm just kind of thinking out loud, making a couple notes out here. I want to fail the vertical line test, meaning I want a vertical line to go through my graph more than once. However, if I want the inverse to be a function, I want it to pass the horizontal line test. So in other words, a horizontal line goes through more than once. You're free to graph whatever you want. We just want to come up with an idea. So for example, something that might work might look something like this. A sideways opening parabola. I can see that that would fail the vertical line test. If I drew a line through it, it would touch more than one time, meaning that graph itself that I'm looking at is not a function. However, it does pass the horizontal line test. Anywhere I draw a horizontal line only touches one time, which tells me the inverse graph, which is a graph I'm not looking at, but the inverse of that would be a function. Something else you may draw, maybe you'll draw something like this, like a backwards dollar sign. That could work as well to fit this definition. Okay, so let's try a couple more, or maybe this is a great time to pause the video and try to make a sketch of a graph yourself. But here are a couple more examples. How about, for the second one, a graph that's not a function and whose inverse is not a function? In other words, it fails both tests. I want something that fails the vertical line test and also fails the horizontal line test. So I want a vertical and a horizontal line to intersect my graph more than once. So maybe something that would work for this is a circle, for example. A vertical line would touch 2 times, so a circle's not a function. A horizontal line would also touch 2 times, so its inverse is also not a function. Maybe you drew something else. I'm just thinking maybe a sideways opening parabola, or like a diagonal sideways opening parabola could fail both tests. So that is not a function, neither is its inverse a function. And finally, our last one wants us to be a function and to have an inverse that's a function. So in other words, we need to pass both tests, the vertical and the horizontal line test. So this one's either really easy or really complicated, depending how you make it, but something really simple that could work and pass both tests is just a diagonal line. That is a function, and its inverse would also be a function. Also, if we graph something like this, as long as that bottom part's not completely flat, that could work as well. We'll take a look at, in a future unit, we'll discover that that's really an exponential growth graph. It's a function, and its inverse is also a function. So here's 2 other examples we could look at too. This time our function was given to us as an equation type thing. I've gone ahead and kind of already made a sketch of this. If you don't believe me that that's what those look like, you can graph them on your graphing calculator. The actual finding of the inverse we took a look at in a previous video, so if you want to find out how to find the inverse, go ahead and watch a previous video. Otherwise, for right now, let's just go ahead and figure out if the inverse of this is a function. To be a function, it has to pass the horizontal line test. I can see from this first graph that no matter where I draw a horizontal line, it only touches one time. So yes, the inverse of this is going to be a function. And just a word of warning, I guess, or caution about this. Sometimes some of these graphs appear to be very flat in the center, and that leads people to say that no, the inverse of this is not a function, because they think a horizontal line would touch more than once. No matter what, these x to the 3rd powers, x to the 5th power problems, even though it looks very flat in the center, it never gets completely flat, and it does only touch one time. So yes, the inverse of this will be a function. For our x to the 4th example down here, I can see that it will fail the horizontal line test. I can draw a horizontal line and have it touch 2 times, so the inverse of this is not a function. And then finally, here's a sort of interesting one to take a look at. They ask us to take a look at the graph of f of x equals x squared. Now, of course, we know that x squared looks like a parabola, so something like this, which, of course, would fail the horizontal line test. However, what they do is they say, well, let's take a look at only part of the graph. In fact, let's look at this where the x is greater than 0. This is just a fancy way of saying, rather than look at the entire parabola, let's just look at half of it, where x is positive. So in other words, instead of looking at the entire thing, let's just look at half of the parabola. So we can kind of put a point right there where the vertex would be. We're just looking at that graph. Well, by adding this extra piece on about the domain, I can see that now it does pass the horizontal line test. So yes, the inverse of this would be a function as long as I'm using this as my domain, where x is greater than or equal to 0.